Good morning, good afternoon, and welcome everybody to another Applied Research Associates ARA Webinar Wednesday program. Today's program is entitled Accelerated Pavement Testing Program, specifically related to implementation considerations. Now it's my great pleasure, next slide please, to introduce my good friend and colleague, Dr. Alvaro Yulara, and I gave that probably was the Sicilian pronunciation of his last name, but I'm sure he'll forgive me. So just a few items with regard to Alvaro. He's been heavily involved with accelerated pavement testing, both on the technology, the production, and the research side since really 2013. He's also actively involved in the business development for this type of testing, program implementation, and the research associated with it. And I'm sure you'll see the sophistication of this through Alvaro's presentation. He currently works for ARA, as all of our presenters do. He's the group leader for the Vertec geotechnical on-site investigation related to comb penetration testing, and also for accelerated load testing program as we go forward. Finally, he's been successful in management and delivery of APT programs worldwide. He's managed long-term APT operations contracts for both Florida DOT and FAA. So with that, I'll turn the program over to my very good friend and colleague, Alvaro.
As far as today, I appreciate the opportunity to present the main aspects related to implementing an APT program. It is a very complex task, but there are several programs that have been very successful doing this type of research. And today I will go from the basics to what an APT program is, what type of programs are there, the facility types, the consideration to select the most effective APT device that will fit the program needs, what type of research can be done with APT technology, and a couple of successful APT program implementation case studies and ROI, return on investment, that has been reported for these programs. What type of benefits can we expect out of this technology? And at the end, I will discuss some of the key factors, both technical and financial, that we need to consider in order to implement an APT program. So again, let's start from the basics. What is an accelerated pavement testing device and a type of experiment? Well, it's a control application of wheel loading to pavement structures. We could be other type of infrastructure, but mainly pavement structures, with the main goal to simulate the effects of long-term in-service traffic conditions. And I want to emphasize realistic loading traffic conditions in a compressed period of time. So what we're trying to achieve is to forecast and measure what would be the pavement or the infrastructure performance when it's subjected to both specific climate conditions, specific construction materials, and realistic traffic-induced loading. So around the world, there are many different types of APT programs. Most developed countries will have one or several APT programs, and the implemented research or the right research needs to be implemented so that both pavement design, pavement construction, and maintenance specifications and applications can be used for the benefit of the agency. So just a few examples on APT programs out there are full-scale test tracks. We all know NCAT, WestTrack, Mean Road, well-known full-scale test tracks that have been operating for several years. Linear devices, APT programs using, for example, Atlas technologies such as FHWA, Illinois, Ohio, New Jersey, and others. And circular tracks. Those are very unique, not well used in many countries, but at least there's a few, such as the one in France, the LCPC, New Zealand, and Spain as well. Now let's look into pavement research and what are the benefits and the costs associated with different methodologies apply to determine what to use for each specific type of research. So first, we all know about engineering judgment, highly applicable. Of course, computer simulation, also highly applicable. The only caveat that I always give to this is that the benefit of a low cost type of computer simulation or engineering judgment is what we always call garbage in, garbage out. The inputs will definitely govern how much value or benefit we get out of computer simulation. We always use this, again, it's very useful, but we need to be aware of the variability in the benefit range based on those inputs. Laboratory testing, we all know, we all use this for research, highly valuable. It will be able to provide significant value depending, of course, on the type of experiment and how close are those laboratory testing to real in situ conditions. We know this is one of the main limitations of laboratory testing, to be able to simulate as close as possible of what would happen in situ, and of course, also the interaction between the different material types and layers that are used on pavement structure. Field testing, also very valuable as well, a little bit more expensive than laboratory testing because it requires a specialized data collection equipment, but this will be able to give us in situ conditions and also interaction between the different layers, so the benefit immediately goes up. One of the most highly used and most valuable type of research or experiments will be the long-term pavement performance. This is a significantly high cost experiments, but will have significant value because you will be able to capture the interaction between the weather, the traffic for many, many years. So one of the main aspects to consider that we are not seeing in this chart is the time. So we know that experiments or engineering judgment and computer simulation and lab and field will take a little bit of time, but LTPP will definitely take significant amount of time to be able to get those benefits. So where does APT fit? Well, APT fit is definitely between the medium and high cost, but will also have significant benefit because we will be able to rapidly, remember the keyword, compress amount of time, be able to get the benefits and simulate damage that will occur in situ with some caveats that we need to take into account, but in a very rapid amount of time. So let's see what's the need for an agency to implement an APT program. Well, there are many, but we know that APT programs will be able to conduct both applied research and fundamental research. So we will be able to effectively capture that distress mechanisms, the failure mechanisms, and the interaction between particles and material types in a very controlled manner. We will be able to use these programs to select procedures for rehabilitation strike evaluation, new product development, innovative construction practices, new green energy type of considerations, sustainability, among others. So there are several examples on which APT programs have been used to either develop a mechanistic empirical pavement design methodology or to calibrate this type of any mechanistic empirical pavement design guidelines. And these, I'm just listing a few examples, such as CRME in Costa Rica, done entirely based on APT testing. CalME in California, also significantly influenced by APT testing. And I know there's several states that are using APT technology to calibrate ash-to-ware pavement ME. And Caltrans also have used that for rigid pavements in the past. Now, let's focus on the APT program types. There are several. I'm going to just highlight the main three types of program types, and I'm going to talk a little bit about of each. So as I mentioned before, one of the most widely used and long-standing programs are the full-scale test tracks. Those are significant, expensive, but very useful programs. And I'm just listing a couple of here. It's important to mention that those full-scale test tracks, the research cycle is typically between 3 to 5 years, depending on the facility and the number of test experiments that are run on those facilities. We will be able to use this data with the actual conditions from the facility, with the traffic-induced loading from the facility, So it will be very useful, but at the same time, it will be tied to the specific conditions that the test track is located in. A fixed facility, such as the FSWA, FAA, and Caltrans and others, these facilities will have the advantage of having one or multiple APT devices, and they will be able to control the proper testing and drive what type of experiments are done on the facility. So that's one of the key differences between the two. And there's also mobile APT programs on which you actually the agency takes the device to a construction site, and they will test on the actual proper conditions of the location, taking into account all the different aspects of the site. Now, if the APT program the selected APT program is more on a facility, there are several types of facilities that the agency can also take into consideration. Some of them are listed here. There are others. These are the most used and highly used. There's one that is used on a construction site, so there's not a proper facility, but the APT device is taken to different construction locations. There's an outdoor that is adjacent to a building. This is one of the most common ones. There are APT programs that use a facility, so there's a complete building that is built around the APT device to test inside the building. Or others use a hangar, and they test inside the hangar for different reasons and different advances that I will cover in a second. So let me go one by one and talk about the main aspects and benefits of each of these type of facilities. So inside a building, we know this will be expensive. You will have to build an entire building that typically are long and tall buildings that will be able to have very controlled access. So it's going to be very easy to control even the environment inside a building. But one of the main constraints is that you will be limited by the size of the building. So keep in mind, for an APT facility, we want to be as close as possible to realistic conditions. And this, of course, covers using real construction equipment, real construction trains that will be able to do exact same practices that are being used on the agency construction sites in the facility. For in some instances, these buildings are constrained in dimensions, so that will prevent the use of either real construction equipment or real construction practices. So let's keep that in mind when this type of facility is selected. Some of the examples is University of Costa Rica, Ohio University, and others. One of the most common APT facility types is a lot that is adjacent to a building. This is less expensive than the actual building that I just described before, but of course there's cost as well into building these type of facilities. It's the most common use and requires more land. That's one of the limitations, because you want to make sure that you have for construction equipment to go in and out and be able to create as close as possible the real conditions that will be done or be experienced on the field. One good example is the FHWA program. Is this type of lot adjacent to a building. FHWA owns and operate 2 Atlas 20 devices. So these APT devices are used on multiple different lanes, and I'm not going to go through all the different characteristics, but this facility is definitely a state-of-the-art facility, very unique features, and this enhances the application of the APT program. It will provide flexibility, and it will assist the program to maximize the benefits. They have even a state-of-the-art water table control system and multiple lanes that are used for APT experiments. Each will have unique features with different construction characteristics, different construction methods and materials. Another example is a hangar and a lot adjacent to a building. So this is in between investment, also gives a lot of flexibility because you have controlled weather conditions inside the hangar, and you're able to bring the APT device in and out easily on these type of facilities. Good examples are Rowan University and the Federal Aviation Administration. on which ARA, we are heavily involved in the research support for the agency. So these type of facilities will, as I mentioned, will have a hangar, and it will have a lot next to it on which we can use the APT either inside the hangar or outside. I won't go into all the details, but FAA uses a significant large APT device, and this is not the APTF, this is a different device on which they will be able to have at least 4 test lanes inside the hangar, around 8 test sections, so give the flexibility to test during winter time inside the hangar with better control conditions and go outside to test other type of experiments as needed. So again, high flexibility and ability to control the conditions better. Lastly, other example of APT facility is one in Laval University. This is what we call a mobile APT program. They are able to take the device and move it around to different construction sites. In this specific example, hopefully you see my screen, they are testing over earth dam. So taking the device with very easily a way, they have an Atlas 20 portable, they just hook it up to a truck, and they just off they go to a construction site. So it's a true mobile program on which they are able to test on different construction sites and different infrastructure as well. They have the ability to have also a facility that they take the APT inside, mainly on sometime in winter, and they also are able to do around 4 experiments inside the facility. But again, they have this hybrid approach of true mobile and also facility type. Now let's talk about, okay, those are the facility types. What type of device does the agency need to select to implement a successful program? So there are many characteristics and factors that affect the overall performance of the program, but also will give flexibility and key unique characteristics of operation. So first of all, that APT device, the selected APT device must, and I want to emphasize in this word, must meet the APT program research requirements and not the other way around. The agency needs to select a program that will be able to meet the research needs. It needs to be compatible with the program type. So for example, there's some agencies that already have land. So they would like to have a fixed facility, and they probably will have a hangar already. So they want to use the hangar, or they don't have any of those, and they want to take the machine to a construction site. So each of those key characteristics that the agency owns or has already needs to be able to influence what type of device is going to be selected. Again, not the other way around. The productivity and reliability of the system is of paramount importance. We want to make sure that the machine is productive and that is able to produce the highest benefits in the least amount of time. The agencies should not, and I want to emphasize this, the agencies should not emphasize in creating a prototype that will take years in testing the prototype. So the agency ended up using or doing more research on the device itself than in actual payment structures, implementation of new materials, and so on. So these are the main key factors. I'll leave this up for you to read, but funding will play a major role. The support that the manufacturer will give to the agency plays a major role as well. Another factor that is considered is productivity. The majority are being judged by how productive and how many implementations can be implemented for the benefit of the taxpayers. So we want to make sure that we have APT devices that are highly productive, and I'm including here a pie chart on average productivity from our Atlas APT devices, on which we want to make sure that the devices are constantly trafficking. Yes, there will be maintenance. Yes, there will be some measurements that needs to be done and forensic evaluation that needs to be done in the test experiments. And of course, as every other mechanical equipment, there will be some breakdowns that need to be repaired, but we want to minimize those and maximize the actual operations, the actual trafficking on the test experiments. We need to make sure that we have a device that can be quickly repaired, that can be upgradable, so it is modular, and can also enhance the research that is going to be done by the agency. I'm going to briefly talk about our ARA acceleration transportation loading system, what we call Atlas. So we are the manufacturer and developer of this technology, on which we provide complete technical operations and research support. It's highly customizable and has several other advantages. We also have an Atlas user group. In fact, we're meeting end of this month in Laval University, on which all the Atlas owners can share experiences and best practices and so on in a very, very effective manner. What are the type of Atlas models that we currently have? And there's several agencies that operate. I showed you the Atlas 20 device, which is FHWA uses 2 of these devices. It's mainly done or used for fixed facility with different type of benefits and alternatives that I will discuss next. The Atlas 20 portable, this is a machine that I was showing you from Laval University, also China. The Jilin Research Institute has one of these machines that they take from construction sites to construction site. Atlas 30, Atlas 80, the number refers to the maximum load that can apply in pounds. And the Atlas 60 bridge, which is called the Beast, and this is mainly used to test full-size bridge decks at Rutgers University. As an overview, the Atlas 20 device has many characteristics. I won't go into each of those, but the load range that can apply goes from 6,000 to 22,500 pounds. So you can see that the damage can be accelerated by imposing significantly higher load than regular trucks. Can apply around 20,000 passes per day in bidirectional mode with a speed up to 7.5 miles per hour and can also do lateral wandering. This is very important because remember, we're trying to be as close as possible to real traffic-induced damage on pavement structures. And has different other features like environmental control, equipment that can simulate and control temperature, even induce rain patterns and so on. The Atlas 20 portable, very similar features than the Atlas 20, but it's shorter. So what I missed to mention is the Atlas 20, this device can actually test 2 test experiments at once, around 20 feet constant speed zones, whereas the Atlas 20 portable can only apply 1 section at a time with a little bit reduced speed around 6.5 miles per hour, but also can do wandering and so on. And as you can see from the slide, it can take from site to site, inside a building or outside, using a self-portable unit. Now, this is an example of a device that is designed and built to meet the existing agency facility. So the frost effect load simulator is a state-of-the-art device that we are developing in partnership with ERDIC, the Engineering Research and Development Center. And this unique device is actually built to fit the frost effect research facility in New Hampshire. This APT device is going to be mounted on rails, and we're going to deliver this end of September, on which we can use actual truck wheel configuration or even a real Boeing 777 landing gear. So we will be able to apply up to 250,000 pounds at up to 8 miles per hour and ability to operate at minus 30 degrees Fahrenheit to simulate real Arctic conditions on equipment or aircraft landing or taking off from this type of infrastructure. So again, a very unique example of how an APT device can be designed and implemented for the agency needs. And again, not the other way around. What type of program research areas can be done or can be used with APT? There are many, and I won't be able to go into all of these, but the most important ones is that we will have, the program will have the ability to test and validate, which is very important, the benefits of using new construction materials. How many times there's a supplier or a vendor that goes to the agency and says, if you use this type of cold mix asphalt, or if you use this type of geosynthetics, or if you use this type of material, your pavement structure is going to last 40 years. It's going to meet and exceed all your requirements. Well, the only way for the agency to test this is to actually use these materials, build a test experiment, and do a long-term pavement evaluation on the material. By the time that test site is being tested and the material is being used on real in situ conditions and real traffic, probably our 10 years has gone, and that technology is not new anymore. There's something even better, something new that comes into play. So there is a significant challenge for an agency to test new materials. And this goes along with new construction practices as well. So APT fits perfectly into that role because quickly we will be able to use in realistic loading conditions and proper construction materials and proper construction equipment and practices, we will be able to test that material on a research experiment and determine if this material will really going to increase the lifespan of the pavement or if this material, on the contrary, is not going to perform well. Imagine the advantages and benefits that the agency will be able to achieve by testing the materials before they go in construction on the actual construction site. Of course, we will be able to test construction practices. There are several agencies, and we deal with multiple agencies, both on the consulting side and the research side, that are not extremely happy with their current construction specification and construction practices. Well, APT will be able to fit that gap. And by filling that gap, we will be able to determine if the current state of the practice is adequate. Is this the best approaches that we need to use and best practices for construction? Well, APT will be able to answer that question quickly. We will be able to evaluate pavement tire interaction, and we can assess what is the impact of using different axle load, different axle configuration, even different tire types. Is super single tire going to introduce more or less damage to a pavement structure? We will be able to quickly, in a matter of a couple of months, be able to answer those questions. We can test other infrastructure. I just showed you an example on testing over an earth dam, but there are other APT experiments that have been done to test bridge joints, to test bridge tests, as I just showed before. So all these different experiments will be able to enhance the agency practices, enhance the use of new materials, and also go into a new realm of applications. What pavement structure is more sustainable than others? What about pavement resiliency? Electrified pavements. I can go on and on of the different research areas, but there are plenty of potential applications for APT programs. Now, let me discuss a couple of successful APT programs and what are the benefits that the return of investment that these programs have been reported in the past. So let me start with one of the oldest ones, and again, one of the most successful ones as well, is the APT program from Caltrans, the University of California, Davis, the UCP RC program, have done multiple different types of APT experiments. I just pick one here for the sake of showing. This experiment was done on I-710 near Long Beach. These are testing rehabilitation strategies. So multiple different test experiments were built to determine which one will last longer under APT conditions and which one will also be better for the agency. So they tested long life modified asphalt concrete, determined the lifespan of that material with APT, same with regular normal standard asphalt concrete pavement and long life joint plane concrete pavement. So they did a life cycle cost analysis and determined failure, and it was proven that the long life modified asphalt concrete was around 7.9 million more cost effective than the regular asphalt concrete pavement, again based on lifespan, and also more effective than the modified JPCP, and mainly due to initial cost. So they run a range of benefit cost ratios using sensitivity analysis, again not taking into account user costs or agency costs, which are a little bit harder to account for. But without those factors, the benefit cost ratio that they got only on one single experiment was between 5.3 and 32.4, which for some of you might sound that is too high, but that's really what we see on the majority of APT experiments, significantly high ROI. Since 1993, the Caltrans program has applied more than 5 billion ESOLs, so more than 250 test sections. And on average, on all those different type of experiments that they have done in multiple years, the average cost ratio for the Caltrans APT program is around 2.8 and 17. So that is significant return of investment for a single APT program. Other good example, and again, I can go on and on different programs, but our good example is the Florida Department of Transportation APT program. They have done, again, multiple experiments since around year 2000. This is just one example. So in 2004, they ran an experiment on which the common practice was to build for heavy traffic sections 2 lifts of modified asphalt mixtures. And definitely cost the SBS PG 76-22. But on the APT program, they tested, can we use only one of the lift as modified mixture and the other lift a neat asphalt mixture? So that they call hybrid structure. So they subjected these test experiments to APT testing. And if you can see my mouse, you see that the both lift unmodified generated significantly high permanent deformation or rod depth with little amount of APT passes. But when they did the both lift modified, you see that it's significantly low rod depth. But to their surprise, if they did this combination of a hybrid structure, one modified and one unmodified, they were able to meet the rod depth failure criteria, which in turn means that they can increase the lifespan of the pavement by not having to go with 2 modified lifts, and most importantly, that they introduce savings. If you count for around 450,000 tons of HMA a year, around $2.25 million per year in saving alone on one single experiment. And as you can see also on the chart on the right-hand side, when the program started around year 2000, 2001, the percent of deficient state highway lane miles went from around 20 to 23% all the way to around 10% or so. And it's going down actually. This year it goes all the way to 2012. But it is not a coincidence. And I'm not saying that this reduction in percent of deficient lanes is just because of the APT. Of course not. There's other factors, but it's definitely an influence on the overall state network condition due to the fact that APT benefits and findings can be implemented for the benefit of the agency road network condition. So what type of benefits can we expect to receive from an APT program? Well, I mentioned already some. We can test new construction materials, innovative construction technologies. We can calibrate pavement performance and thus fine-tune pavement design methodologies. We can actually look into sustainability in a more accurate way, in a more rapid way. We will have tangible and intangible benefits. We all see the tangible ones: reduction in construction costs, savings throughout the agency, better vehicle cost operational cost reductions, but also intangible. We can develop human resources. We can train future engineers that will go to industry, to academia, and back to the agency with way better knowledge on different better practices as well related to APT and construction specification development. Now, let me focus now on the program implementation factors or key considerations. So as far as the operation consideration goes, we need to develop, the agency will need to develop a strategic APT plan. This is like a roadmap of, and typically it's every 5 years, what type of findings are expecting to be generated in the next 5 years. So we're always ahead of the experiments and what type of devices, of technology is going to be evaluated. What are the agency goals? This is, again, as I mentioned before, one of the key advantages of using a facility APT type of device is that the agency is in the driver's seat of the experiments and the type of research that is going to be done. It's not a function of what type of experiments other agencies need, is what the agency, the proper agency is going to be using local conditions, local materials, local contractors that will play a major role in the implementation, the successful implementation of the program. It's very important to collaborate among other APT programs. And with ARA, we always entice programs to share experiences and make sure that they have good handle of what others are doing. And again, we want to make sure that the program hopefully can run as close as possible to 24/7 for maximum productivity. The stakeholders will play a major role. The agency, as I mentioned, is always in the driver's seat. But an operating advisory group is always good to have. This group of stakeholders will be able to determine and assist the agency and what the needs are, and also to report back what type of benefits and measure what type of benefits are being implemented. Universities, research centers will play a major role. This is a collaborative effort. Industry as well, state partners, associations like the Lime Association, the Asphalt Pavement Association, the Cement Association, all these type of stakeholders will play a major role. So it's not the agency sitting and telling all directions of what's going to be done. It's a group effort on many different stakeholders working together to make sure that the program is successful. As far as financial considerations, some agencies make the mistake to think only on the initial cost. Let's acquire the IPT device, let's acquire the line, let's acquire, or let's just make sure that we have a significantly large area for a test track. But that's only the beginning of the story. And I'm here to explain what other factors need to be taken into account. So of course, initial cost, and I won't go into all of those details, but you will have to acquire that device. And again, the device that will meet and exceed the agency requirements. The agency will need to either get the land, acquire the land, or use existing land. Sometimes the agency will partner with a university, and the university will donate the land, and they will use the land for the APT program if it's a fixed facility. Or in the contrary, it might be that there's no land and the APT device will need to go to different construction sites. And that's also valid and applicable. The facility might be that there's no facility already built, but it has to be built. So that will have extra cost. Instrumentation, forensic evaluation equipment also is part of the initial cost. So that is done at the beginning of the implementation, and that is taken care of. So typically these costs will go up and down, but it will vary between $4 and $6 million as initial cost. It could be lower if there's a partnership with a university, which we see this a lot in multiple different agencies, but if it's not, it can go on the high end of the cost that I'm showing here. But then it costs the annual recurring cost. And this is very important to keep up because the program will not last for many, many years as it's intended to be if there's not a constant flow of funding. And I want to emphasize on this because this is where the partnership comes into place. You will need to have human resources dedicated to run the APT program. What type? Well, you have an APT chief operator, you have technicians, you have research engineers that hopefully this will come from either a support from a consulting firm, or they are coming from the university or even the agency if they have the resources. The pavement test section needs to be built and needs to be instrumented. So in this portion, I know several agencies will partner with contractors and they will donate the construction of the test experiments. And this is very good for the contractors as well. That's like a feather that they can use in their cap because they are helping the agency to build state-of-the-art experiments by donating their time and effort to construct these test experiments. So that is something that has significant savings, but also I'm including here in this table just to show what could be if that's not existent. Pavement instrumentation, there's some instruments that can be saved after an experiment and recycled for the next one, but there's some that are going to be lost during the experiment. So there needs to be constant acquisition of and purchase of this type of instrumentation. There will be spare parts and consumable for every device that is used for APT research. That also needs to take into account. And there's also, and we offer this to all our ARA Atlas owners, a maintenance agreement. So that's also additional cost, but we need to make sure that the machine is fine-tuned. And when the machines are used for APT research, then that is a perfect time to do maintenance to make sure that everything works just fine in preparation for when the test experiments are fully built. So in summary, the APT programs will have significant benefits for the agency. It will have a direct impact on the agency's road network condition. We will be able to test new materials in a very compressed amount of time. We will be able to select the most cost-effective construction and infrastructure and design and construction practices. We know and we understand that an APT program is a major investment for an agency. Those programs are definitely not cheap, but it will bring significant value for the agency as far as implementation of results, collaboration with different entities such as universities, association, industry, and such, so that benefits, both tangible and intangible, will be highly 100% directly impacting in a positive way to the agency overall road network condition. The APT program will allow the agency to quickly, and I'm going to highlight that word, quickly implement the findings that are 100% applicable to the agency's conditions. So the new material, the construction types, the pavement design, the construction practices can be applied immediately to construction specifications, construction practices that, again, will highly benefit in a very short amount of time, will highly benefit the overall road network condition. One of the most important aspects is to have close collaboration with other APT owners, which we highly encourage that. We as ARA, we also provide research support, and we definitely are there to help agencies in every step of the way to make sure that the APT program is not only successful, but also long-standing. Those APT programs, it's not rare to talk about 20, 30 years and it's still up and running, still bringing benefits. Some agencies start with one APT device, but the results and implementation are so valuable, the return of investment is so high that the agency ends up acquiring a second device. And we see this across multiple different agencies in the country and outside the country as well, on which there's so many experiments, there's so many benefits that can be produced with this type of experiments, that at the end, the agency ends up introducing more funding, more collaboration, and better conditions for the taxpayers. So with this, I would like to end my presentation and turn it up to you, Jerry.
Okay, thank you, Alvaro. Pretty interesting. That could, not my area of specialty, but this could easily be a one-day short course on this topic. A lot of information in the limited time we have available. Before we get to the Q&A period, I'd like to share with you, as we always do, some up-and-coming webinars. And on September the 18th, we're going to have a slightly different topic that might be of interest to many of you. As you're probably aware, most of you know, ARA has a pretty diverse range of capabilities in different offices. So the title of that presentation, presented by Hans Boder, is going to be Predictive Modeling of Dredging Needs. And everybody's aware of the unfortunate collapse of the Key Bridge and focus on navigable waterways and preventing future disasters such as the Key Bridge. We're currently planning the specific dates for our October and November program, but we've had seminars scheduled and technical presenters, all of which are ARA presenters, through the early part of 2025. So if you're interested in the up-and-coming webinars, please register at the site you see on slide 41. I'd also like to remind you that all of our webinars are recorded, so if you have colleagues that missed today's program or yourself want to revisit portions of today's program, you can take a look at that same site and look at any of the webinars that have been recorded. This happens to be, by coincidence, the 5.5-year anniversary of this program. So now we'd like to enter the Q&A program, and as all of our presenters graciously do, Alvaro has agreed to entertain questions for the next 24 hours or so on this specific topic that he's speaking about today. Please form your questions not in the context of consulting, but general technical questions. He'll be more than happy to communicate with you. And now I'd like to spend a little bit of time looking at the questions that we've received, and we have a number of them. We hopefully will get to several of them, but I'm doubting that we'll get to all of them. So Alvaro, the first question is, could you elaborate a bit more on the Cove Regions facility with regard specifically to the freezing process of the test section and whether or not the test section is constructed within a large cooling chamber?
That is a great question. So the Frost Effects Research Facility is a state-of-the-art facility, unique in the world. I don't know any other place that can do something like this. They have a very advanced cooling system on which they use glycol-based technology and air chillers to reduce. It's an isolated facility, 300 feet long facility, on which they can reduce the temperature under controlled conditions on the entire hangar. This temperature can go as low as minus 10 degrees Fahrenheit, and they are actually working on upgrading the system and being able to go as low as minus 30 degrees Fahrenheit. So the entire facility air temperature will be under those conditions. In addition to that, we are also working with ERDIC to develop frost panels. These frost panels can be installed on top of the different pavement layers, and we can induce frost effects on those layers. So there are multiple different ways to induce very, very low temperatures. Again, being able to simulate Arctic type of conditions so that these experiments can be as close as possible to realistic environmental conditions in the Arctic.
Okay, that's great. All these things are quite involved, obviously. So extremely good question and great answer. Second question that we have is one of the participants noticed and was intrigued by the range of the benefit cost ratios you showed on slide 32 and was interested in how those benefit cost ratios were computed and what variables were considered.
That's a great question. And this is one of the main aspects of APT programs that are difficult to track, but are of paramount importance. So each agency will have different approaches on how to determine the benefit cost ratio, but the vast majority will take into account the cost of constructing the site, the cost of the depreciation of the device, the cost of the instrumentation, and the cost of running the actual experiment with all different aspects, the human resources, the power that it takes to run the experiment, and so on. So that is on the cost side. On the benefit side, this is where it changes. So the majority of agencies will not take into account user cost, because once you account user cost, frankly, those ROIs will go through the moon. You start talking about hundreds, in the hundreds, because the user cost definitely will bring additional value. But user cost is hard to predict or to quantify. So for that, the agency would typically not account for user cost, only for the benefits, how the benefits are accounted for. And I just gave a couple of examples. So for example, if in that example from Florida, if the agency now, instead of using two different asphalt modified mixtures, only uses one lift, so that will at least introduce 3 inches on a number of miles that are going to be used with neat asphalt mixture. So the difference between the two different material types, that is cost savings. Those cost savings is taken into account into the benefit calculation, and that's how you can derive the benefit cost for each of those experiments. And that's just one example. There are many different applications of how the ROI is calculated, and that's something that we are talking to the TRB AKP 40 committee so that we can provide guidelines, and that guidance can be developed so that all agencies will use the same methodology to determine the ROI. I think that will be highly beneficial for the APT community.
Okay, thank you. Next question is on slide 33. Jose would like to know, what did you mean by neat layer of PG?
Yeah, what I meant here is that, as I mentioned before, the hybrid structure would use a polymer modified SPS PG76-22 as the top layer, and a neat asphalt mixture that is not polymer modified. It's a neat asphalt PG67-22. So the difference in cost, because you're not using polymer modified on the bottom lift, is significant. And that's where, based on the number of miles that FDOT builds with this hybrid structure, comes cost savings of not having to use the no polymer modified mixture of around $2.25 million per year.
Thank you. So next question is, how would you recommend monitoring pavement distress during the actual APT experiment?
That is a great question as well. So there are multiple different ways. One is to do a manual distress survey every often, for example, every 10,000 repetitions or every 50,000 repetitions. We actually scroll down and with a chalk and we start marking what pavement distresses are there. Also, there's technology that we have developed based on the PaveVision system, and I have a slide that I can show quickly how does it look. So if you can still see my mouse cursor, you'll be able to see that this technology or this type of device is attached to the load carriage. So it's an onboard solution on which certain number of passes with a click of a button, a permanent record of the test experiment is created, and later we can import or export, these high definition images and track the evolution of these stresses. So this technology is highly beneficial, and we have it available on our Atlas systems for the owners to include this into their experiments and run the PaveVision distress survey every so often. So they can do this, as I mentioned, every number of repetitions. They will create this permanent record and track the evolution of distresses on the pavement. Also, we do have on board a laser profiler. So we can do a transverse measure, very accurate, using laser-based technology, and track the evolution of drop depth on flexible pavements. This can also be done if there's potholes or any other type of deviation from a true planar surface. And we can also measure what the pavement profile is based on number of APT cycles.
Well, we're running a little short on time. I want to apologize again for that little technical hiccup that we had at the beginning, but you see Alvaro's email address here. If you didn't have time to formulate your question, or we didn't have time to get to your question, we will get to your questions, and feel free during the next day to submit supplemental questions. So just as a reminder, all of the participants who have joined for the entire full hour of this presentation be entitled and will receive a 1-hour PDH certificate plus a PDF copy of today's presentation. I mentioned, I believe at the beginning, 2 weeks. Sometimes it takes us 3 weeks to receive your certificate. You should have no problem getting that. If you do have any problem, just communicate with us at the address that you see here. Well, like everybody, I guess, ARA is hiring. We are hiring lots of people, as we did during the past year or so. If you're interested in employment opportunities, specifically with ARA's transportation and infrastructure offices, please send a brief resume and your contact information to the web address that you see here. Now, I want to highlight transportation and infrastructure offices. ARA has 6, as I count them, 6 different business lines. I think that does it for us for today. We're out of time and we're out of slides. You all have a blessed day. Join us on September 18th to learn about how we model dredging. Very interesting topic for our navigable waterways. So have a blessed day, and thank you all again.